Hello, it's Dr. Bhatt here. The topic today is very interesting, and the topic is the contact angle, how contact angle affects the wetting characteristics of a liquid. Because we find that whenever a liquid is taken into a container, the sides of the container are normally wetted. They become wet with the liquid taken in the container. So this is the topic of our presentation today. Now let us see what is there. There is a diagram, of course, I can show represented here just to consider the wetting properties of a particular solid surface by a liquid drop. Considering water as a liquid drop, if it is taken into three solid surfaces of the same type, same size, and then what happens, we are going uh, to observe. Now here we find that in one of the case, the solid surface, the liquid drop is there, and the contact angle represented by theta is known as 90 degree. In the other case, we find the same liquid drop is there, but the contact angle is greater than 90. Greater than 90 means an obtuse angle is formed. And what is contact angle? We have already got an idea about it. Contact angle, I repeat again, is the uh, angle subtended by a tangent drawn at the point of contact of the solid surface with the liquid surface. That is contact angle. And here we find that the contact angle of the same liquid drop is being considered is different in different solid surface. In the third case, we find that it is lesser than 90, means an acute angle is formed. Different contact angle on the same solid surface. And what is happening here, if we watch carefully, we find that the contact angle are different in different cases, considering the same solid surface and the same liquid drop of the same liquid. Now, we find that this liquid is in contact with the gas phase also, the air above. Normally it is air, isn't it? And then the solid is also in contact with the gas phase. And the liquid drop itself is in contact with the solid. So three different phases occur here. And it is the outcome, the wetting property is the outcome of three different phases and the contact angle. And these phases, when which occur in different materials, we call them as interfacial tension, not surface tension. The tension between two different phases is similar to surface tension, but it is known as interfacial tension. So now here we find that different contact angles are there on the solid surface. Repeating again, in one case it is 90 degree, it is in another case it is greater than 90, in the third case it may be less than 90. And we find that droplet has a flatter shape with edges more conforming to the solid surface with lesser contact angle. Here you find that the liquid is spread well over the solid surface. Whereas with obtuse angle, if the contact angle is greater than 90, the solid surface is not wetted, or there is a poor wetting. And when it is 90, we find that the liquid drop is just touching the solid surface. So that's there. Now let us consider something more. If the liquid contact angle is 0, what will happen? Practically, a 0 contact angle may not be possible. Liquid spreads over outer surface of the indicating complete wetting. It is just spreading out of the liquid. Okay. Zero contact angle means the liquid will spread over there. And such a solid surface is known as hydrophilic surface. It loves water. The meniscus in capillary tube has a concave semi-spherical shape. Now suppose the contact angle is 180, what will happen? Such a surface hates water, hates the liquid, and it is a non-wetting surface or hydrophobic. The liquid forms nearly spherical shape, spherical droplet with poor wetting. Now, a contact angle is also considered as a measure of the angle at which a liquid vapor interface meets with the solid surface. A similar diagram is here. There is a solid surface. There is liquid over the solid surface. There is a drop of liquid over. And then three different interfacial tensions. We have discussed about interfacial tensions. Three different interfacial tensions come into play here. And that interfacial tension is known as gamma if it is between solid and liquid, gamma between solid and gas, and gamma LD, less liquid and gas. And theta C is the contact angle. Now this is a schematic diagram of the liquid drop on the solid surface. Gamma represents the interfacial tension between different phases. Theta C represents the angle of contact. Now contact angle is the combined effect of interfacial tensions between solid liquid, solid gas, liquid gas. And uh, it can be calculated using Young-Laplace equation that gamma Sg is equal to gamma Sl plus gamma Lg cos theta c. That is known as Young equation. Now more details about this Young equation. We need to go through different derivations and calculations, etc. in our studies in physics. Therefore, it is advised that one should go through the physics studies also here. Now, we stop here. Students, thank you.